Hi, good morning. So what we're going to do in this lesson is put the Excel skills that hopefully you learned by watching my video over the weekend. And we're going to actually use Excel skills and math skills to model data. Okay? And I hope by now you know that modeling data really means coming up with some sort of mathematical formulation to fit data. So I think I've mentioned this to you before, that what I did this summer was actually do a fellowship at Santa Clara University in the Robotic Systems Lab under being directed by Professor Christopher Kitts right there. And what I did was, actually what Professor Kitts did was gave me this paper and says, hey, see what you can do with this. And so I browsed through this paper, and a lot of it was, to be honest with you, a bit beyond me. It's been years since I looked at satellite technology and all that stuff. But I was really looking at it from, what nice math could I do? So I read the paper, kind of ignored all the biological stuff. I'm not into biology, otherwise I would have become a doctor. So I, looked at all the diagrams in there and said, yeah, okay, great. Ooh, now I'm beginning to see things. There's data there. Okay, and data means, graphing, equations, stuff like that. And then browsing more, and I look at this picture here, and I said, oh my God, that looks really interesting. Hopefully it looks interesting to you. Tell me, what do you think that's all about? I mean, this stuff here, these nice graphs here, okay? Hopefully you recognize that these are sinusoids, okay, or sine waves, okay. So I was really lucky, I'd say, that this data was actually there, and I could actually do some sexy math with this. So that's what really got me excited. So again, let me just emphasize that what this paper does, the paper that I just showed you, that was written by Professor Kitts and his colleagues, some at Santa Clara University, some at NASA Ames Research Center, and I think one guy from Stanford. So what it is actually data that they've collected in what's called a small satellite. So a small satellite is about 10 centimeters by 10 centimeters by 30 centimeters. And what I'll show you here is a simulation that a student at Santa Clara University did to show the trajectory of the satellite and what it kind of looks like. Okay, so let me see if I can get this going. There it is. Okay, so there's the globe, and now lo and behold, you can see the satellite coming through. Okay, so like I said, it's a fairly small satellite, 10 by 10 by 30 centimeters, and it's called a CubeSat satellite. And the three lines that you see there, the red, green, and blue, okay, those are the axes of the use in simulation. There are several axes that one can have, but this is one set that the student selected to show. So you've got the satellite that's going around the globe, and it passes overhead, and it transmits data that's collected by antennas that are at Santa Clara University, and they store the data and do whatever processing they need to do. Okay? So just to set the stage up, so that was just a satellite simulation that was done by a student, Anthony Young, at Santa Clara University. So nice of him to really do that. To me, I'm just totally amazed. Every time I do this fellowship and I look at all the sexy engineering that goes on, it just blows my mind. And at Santa Clara particularly, what I found was that in the robotic systems lab, it was a lot of it was hands-on. I mean, they were actually building things, which to me is just great. Unfortunately, my experience in grad school wasn't quite like that. I just did a lot of theoretical work and did a lot of paper pencil kind of stuff. And yeah, I did a lot of math, and extreme math. But this really got me very excited. So we're going to be looking at data that Santa Clara has generated. And what I've done is I've taken a file that Professor Kitts gave me, or actually one of his students gave me, and I extracted some data and I've put it under our Google Groups. Okay, hopefully by now you're familiar with my Google Groups. You should have signed up for it, and it's at groups.google.com/group Karmali, Calc Karmali 2010, as you can see it right there. Okay, so there is my web page for the group, and you'll see that there's a file up there called window-temp-data.xls. So let's go open that file. Okay, go open that file. It's going to show up momentarily, I guess, depends on how fast the internet connections are and so on. So let's kind of wait around, see how long it takes to get this. Oh, there it is. Okay, does it slowly. At first I was going to do using spreadsheets using Google and experimented with that during my summer fellowship, and it was painfully slow. And knowing how impatient you guys are with computers and how you like to get things done, I decided that the Google document products are not going to work for us, and instead we're just going to use Excel, and those should be available on the computers in the lab. Okay, so I'm going to go open that file. Yeah, it's just truly amazing why this is so slow. I probably depends on the network load and things like that, but my recollection is that when I did do it the first time, it wasn't that slow. But well, whatever it is, let's kind of bear with it. And so you're going to see data that I've actually extracted from a file that the Robotic Systems Lab has put up there on the web. Okay, and come on, dog, move on, move on. Okay. So just to let you know, I'm not going to, well, what I'm going to do is I'm going to walk you through all the steps that that you need to take to complete the work. So this is really a post-processing kind of video, meaning that we'll have done an exercise in real time in class, and then I'm going to post this little clip up there on the web for you to kind of review before you send in your work from the lab. Okay, I didn't want to actually just post this thing on the web and then have you kind of watch it and then do the activity. I feel it kind of takes away from some interactiveness in my lessons. I like to kind of quiz you and question you and prod you and move you along. So this is trying to download slowly. Let's see how that goes. Okay, there's some hang up, I don't understand. All right, so here's all the data that that was in that file. Okay, and what I did was the file's got data being collected from from the initial launch to whenever, and what I did was I actually went in to the paper and I looked at the time here. Okay, this is what you see as time in counts. Okay, and I said, okay, I need to look at data over this period of time. So then if you come back, so the time that you saw in that graph is this guy here called T-stamp. It really stands for timestamp. So timestamp is merely some sort of a counter that goes along with data collection sequence. And so you see various data here. Okay, so entry number here is essentially saying what data element it is. Like this is this whole row here, the first top row here is the 43,912th data entry, okay, in some particular file. And just to go over some of the variables that that they've collected data for, okay. So there is your timestamp. T-stamp is timestamp, okay. Then you've got acceleration X, acceleration Y, acceleration Z. So those are your three accelerations